All right, so now next second part of the second of the two parts is to find whether each of this is a minimum, maximum, or a saddle point. Okay, so we need to calculate the discriminant. So remember the discriminant is fxx times fyy minus fxy squared. Okay, so that's the key thing to determine whether it's a uniform concavity on every side, or if it's non-uniform. If this is larger than 0, it's uniform concavity, meaning it's either a max or a min, or if it's so in every direction, it's basically the same concaveness or curvature. And if this is larger than 0, it's that. If it's less than 0, then it means in one direction it bends one way, it curves one way. In another direction, it curves another way. So it will be a saddle. Okay, so let's calculate this for each of the point. So let's calculate that for 0, 1. Is that my first point? 0, 3. Let's do 0, 3 first. Okay. In fact, I need the second derivative. So let's do that. So what was it? Fx was, if I look at what I had earlier, was 2x plus 3y minus 3. This one. And fy was 3x 2y minus 4. 2y minus 4, yes. Okay, so now if I do fxx, I will get 2, and that's it. Fyy means the second derivative on y, which will get 3x times 2. All right, so 6x. And let's do fxy as well. Fxy is, I can either take fx and differentiate y, or I can take fy and differentiate x. Which one's easier? Looks like if I take fy differentiate x, it's easier. So I'll just get 2y minus 4. Okay, so 4y minus 8 essentially. All right, so the discriminant at 0, 3 is fxx is 2, fyy is 0, minus 4y is 3, minus 8. Okay, so remember the brackets. All right, so that's 12, 4, okay, minus 4. All right, so that means it is a saddle. Okay. So let's write this properly. Okay, and now let's check 0, 1. So that's the second critical point. So we have, again, 2, 0, that's the fyy minus 4. Now let's put a 1 in there, 4, 1 minus 8. Yep. Okay, so I have plus 4. That means 0, 1 is either a minimum or a maximum. Okay, so is equals to either min or max. To find which one it is, I need to check the fxx. So since fxx at 0, 1 is 2, which is larger than 0, that means it's a minimum. Okay, so 03 is a saddle point, and let's write proper sentences. So therefore, 01 is a minimum. Okay, and finally, we check 3 over 2 and 2. Is, yep, 3 over 2 and 2. So we will have 2, that's fxx, and 6 times 3 over 2, that's fyy, minus 4y minus 8. So 4y, so that's 2 minus 8. All right, so that's 0. And I get a positive value. I don't really even need to evaluate what that is, but it is 18. I just need to care that it's larger than 0. So if it's larger than 0, it is either a max or a min. and we check that fxx is also larger than 0 because fxx is a constant. So this point is, I can just squeeze this in here, free 2 is equals to a minimum. Okay, sorry, I was just looking at my notes and I'm being a bit blind today. Notice I made a mistake here when I do the second derivative. Well, I made two mistakes. First of all, when I do the second derivative, I need to differentiate this with respect to x, but I copied that wrong. That shouldn't be a 2, that should be a 3. Okay, so that does change things because now this is 6y minus 12, right? Lesson over here is make sure in an exam, make sure you double check things. This is particularly easy to double check because if you do fxy and fyx, you can take this, for example, fx and differentiate that with respect to y and double check that. So let's do this quickly. So this part is y squared minus 4y plus 3, right? So if I take fx and now I differentiate it with respect to y, then I will have the first term goes away, the 2x goes away. Right? So now I have 3, and then here it's 2y minus 4, right? So here I have 6y minus 12. Yeah. So then you can double check that everything is in order. Okay, so that's mistake number 1. Did you spot my mistake number 2? This is a square. Just for the dimensions to work out correctly, there has to be a square. So I forgot all the squares. So let me fix one thing at a time. First of all, this should be, this should be 6 and 12, and that should be a square. This should be 6 and 12, and that should be a square. That will definitely change things over here. And finally, over here, we have 6 times 2 minus 12, right? And the square. Okay, so all of those should be this way. And now let's evaluate this. This is minus 6, so 18 minus 12, so plus 6 squared, so minus 36. There's another quick way to see is this part is 0, and then you're minus saying something squared. So this has to be negative. We just need to know, if you remember, we just need to know whether the discriminant is positive or negative to determine whether it's a min-max or a saddle point. So I guarantee that these two are less than 0 because it's 0 minus something positive, something squared. As long as I don't have any imaginary numbers, I'm fine. Yeah, so, but let's just do this for sure. So 6 minus 12, so minus 6 squared, 36, so minus 36, of course. Yep. So both of them saddle point. Okay. And finally, we have this case. What do we have over here? This is 0, right? So this goes to 0, and basically just the first part of it, which actually gave me the same answer by luck. I got the exact same thing over here. Okay, so same conclusion, that's a minimum. All right, so here's the solution for you. All right, let me know if you have any questions.